So let's take a look at the augmented matrix. So if I print out this matrix, which I have in C, that's your system of equations. 1x minus 2y plus 3. Oh, you know what? I gotta enter in those values in that last column. So that last column, basically the
It's
right hand,
21.
yeah, 21, negative 10, and then 37, right?
Mhm.
Now there's two ways to solve this. If you're stuck solving it by hand, here's what I would do. And even though I'm going to use program row ops, you could still do it by hand this way. It's just going to be a lot easier for me than it would be if I have to do this by hand. Now, what I want to do is I want to use the rows of this matrix to one at a time get variables, excuse me, get zero here where there's a negative one, below that where there's a two, and next to that where there's a five. I want to get zeros all those places.
So you want to get the row echelon form.
Basically, yes. So the way I can do that, first of all, is to add row one to row two. So let's do that. And I'll do it this way with the fourth operation. Multiply row one by one and add it to row two. And that gives me
Is there a function that will get you row echelon in the
yeah,
calculator?
there's actually a little button you can push to do that. Sure. Let's keep going though. Let's get a zero here where there's a two. So to
Times
do
the
that,
first row by -2.
yep. So multiply row one by negative two, add it to row three, and bam, we're looking pretty good. In fact, this one looks like it's set up to work out very nice for you because the last thing I want to do is add row two to row three. That's going to put a zero here. So let's do that. You could just do a row add. I'm just still going to stick with this one. Multiply row two by one, add it to row three. And now that's great because you can see that, well, you get this last equation, 0 plus z equals 6. So z equals 6. If z equals 6, then you can plug that back into here and calculate what y is, right? Y plus 2 times z equals 11. So it's going to be y plus 12 equals 11. If I put that in there, then I can solve and get y equals negative 1. So now I've got y and I've got x, and I can plug it back in here. Excuse me, I've got y and I've got z. I can plug it back in here and solve for x. So that's probably the way I do it on an exam.
Do we not need to get the zeros above the ones?
No, that's
No.
working way harder than you need to. You
Okay.
see, you can read off the z solution.
Yeah.
And once you get z, then you can figure out x, or excuse me, then you can figure out y from the second equation because you know z. And then once you know y and z, then the only unknown in this first equation is x. So you're set. This is geared to work out just right.
Oh.
Are you okay with that much?
Yeah, no. That's fine.
All right, let's exit this. This is if you're stuck doing it by hand, this is the way to do it. So let me get out of here. And if you want to just do it on a calculator, you just want the answer, then let's go to matrix menu, go over to math, and let's see here. You want not just row echelon form, which is this ref up here, you want reduced row echelon form for that augmented matrix. So let me just put in that augmented matrix that was in C, and bam, there's your answer. So you got the
reduce
zeros
row
above that
echelon.
below. What's that?
Okay, so the reduced row echelon is the zeros above the ones, and then row
Zeros
echelon is
above and
just
below. You don't need to
okay.
go that far if you're solving it by hand. Because once you get the zeros below, you can figure out what the z is. Then you use that to figure out what the y is, and you use them both to figure out what the x is. So that's one way to do it. Now, another way to do it is with the matrices and an inverse matrix. So let's take a look at these two matrices. There's your matrix of coefficients. Just clear this out, do that again. So here's your matrix of coefficients. And then the right-hand side of this system of equations is in B. So our systems of equations is basically AX equals B. And in order to get the solution, you're just going to multiply both sides of this by the inverse matrix. I think I've got an example like that. Give me just a second here. Oh, where would that be?
Well, wait, can't you just like plug in, can't you just like manually type the matrix A to the -1 power?
That's that's what I'm going to do. Yeah. I was just trying to find where I've got it all written out here for us. Uh, maybe it's in chapter 4. Perhaps. No, I'm not finding it at the moment.
Yeah.
System of equations. Yeah, it's in 12.5. Yeah, I just wanted to give you something to look at here, but I'm not finding it.
That's so true. That is true.
Let's try. 5, 4. Sorry, I don't have it.
It's okay.
All right, so anyways, we want to calculate the inverse of this matrix times B. So we want A inverse B. So go back to your matrix menu. So that's going to be, let's pull this out. You can follow along the keystrokes down here at the bottom. Second matrix, type number 1. And then hit the inverse key. And then second matrix again, B. And I should get the same solution that we got when we worked with the augmented matrix, which was 1, -1, 6. Beautiful. Now, if you have to calculate A inverse by hand, that's a royal pain.
Yeah, we just got taught the equation. It was like 1 over AC minus BD or
Well,
whatever, and
that's
you have to
only in the
multiply.
2. That's in the 2
So
by
two
Oh,
kids.
that was 2 by 2, yeah.
Yeah. If you have to do it in the 3 by 3 case, let me just kind of hint at it in the 3 by 3 case. So let's take matrix A, and I'm going to store that in matrix D just for convenience. And then I'm going to edit that matrix and make it a lot bigger. So matrix D, I want to edit that. So go over to edit and then down to matrix D. I'm going to make this matrix double in size. Instead of 3 rows and 3 columns, it's going to be 3 rows and 6 columns. And then what you want to do is you want to fill in that extra 3 spaces with the identity matrix of the same size. So like this. So now let's take a look at that matrix. And it looks like this. So here's your matrix, and next to it, I've written the identity matrix. What you're going to have to do is play around with this matrix of coefficients by adding, subtracting, multiplying, etc. and work with this until the left-hand side looks like the identity matrix. And once you get the left-hand side to look like the identity matrix, the right-hand side will be your inverse. So let's kind of take a sneak preview at what we're going to get. If I take a
This is
look at,
terrible.
oh, it's a lot of work. I won't kid you on that one. Here's our matrix. If I look at the inverse, that's what I should eventually get if I work with matrix D. I'll just do a couple operations to show you that that's where it's headed. You know, getting all the way there is kind of a pain. What you're going to see is a lot of repetitive calculation from what we did earlier. So let's go back to program row ops because I'm not doing this crap on hand. And glad that you still have that program there for you. Select
Yeah.
matrix, that's going to be 4. I hope this works. We're going to multiply row add. I want to, chose the wrong matrix. Let's put that matrix in matrix A. Might be something from program. Let me try that again. Program, row ops, matrix A, multiply matrix, or multiply row 1 by 1 and add it to row 2. So I'm going to go kind of fast because we've already done this for the row echelon part. So I got a 0 there. I need a 0 here. You want to do this in exactly the order I'm doing it, otherwise it'll mess you up. I need to get a 0 here. So multiply row 1. Oops. I pressed the wrong 1. I think this is just a row spot. Okay, so we're good. So let me try this again. This time, multiply row add, multiply row 1 by -2, add it to row 3, add it to row 2, no, add it to row 3. Okay.
But you want to get on the left-hand side, the identity matrix, and
So
then
I know,
the right-hand side will be the inverse.
right? So you got to keep going. Let's just see if finishing up's really that bad or not. It's probably contrived to work out nice. Let's get the 0 here. So multiply row add, multiply row 2 by 1, add it to row 3. And now you got to do the same thing working up. This time I'm going to start with this number here, the 1 in the bottom right hand corner, and get zeros up above. So multiply row add, multiply row 3. Let's see, by -2 and add it to row 2. And then you got to multiply row 3 by -3 and add it to row 1. So let's do that. 4, multiply row 3 by -1. No, by -3, my bad.
Yeah.
By -3 and add it to row 1. So now we got those cleared out. The only thing we have left to clear out is this -2 here. And now you're going to use this pivot because you don't want to use this row or anything like that because they've already got the zeros there. So you're just going to use this one. So the last part here is a multiply row add. You're going to multiply row 2 by 2 and add it to row 1. And bam. Take a look at this right here. That right-hand side is your inverse matrix. That's what we got in like 3 seconds when I just pressed the right buttons earlier. But if you had to do it by hand, that would be how to do it.
Thanks, Dan.
All right, I'm going to stop the recording, and if I get a chance, I'll try and post this on YouTube for you at some point. See, there we go.